Addressing a challenge from ISRO and IIT Delhi, cargo chaos on the ISS wastes astronaut time. Our mission is to build an intelligent storage management system. It guides placement, speeds up retrieval, optimizes space, manages waste, and logs everything, all deployed efficiently via Docker. Our system, powered by a fast Rust backend and a Next.js interface, makes storing new items simple and efficient. When new cargo arrives, our placement logic rapidly finds the best available spots inside containers. We use smart packing strategies, like 3D bin packing heuristics, to figure out where things fit, even considering rotating items. Importantly, high-priority items are placed in their preferred zones and closer to the front for easy access whenever possible. If space runs out, especially for critical items, our rearrangement feature kicks in. It cleverly identifies lower-priority items that can be moved with minimal effort, suggesting a clear sequence of moves to free up the needed space. This whole process, even for thousands of items, is remarkably quick, taking just tens of seconds to compute the optimal placements and rearrangements, significantly reducing astronaut workload. Okay, you can see all items are now placed within their zones. Let's zoom into the Power Bay zone. Here are its containers listed with their dimensions, weight, and know of items. Now, let's peek inside container PB01. Clicking it reveals all the items stored within. Selecting the specific item shows its details: ID, name, priority, expiry date, and remaining uses. To make understanding the storage easy, we offer an interactive 3D visualization for each container. You can effortlessly switch between top, side, and front views. This gives a clear, detailed picture of exactly how all items are packed inside, showing their precise locations and how the space is utilized. Need quick info? Our intelligent chatbot uses RAG to directly query the database and answer your questions. For instance, ask, how many items in containers? It accesses the live data and replies, 2,000 items in 56 containers. You can also ask for specifics like, show all expired items, and the chatbot retrieves and displays that list instantly from the system. Finding items is fast with our search bar. As astronauts type, it instantly displays matching items and their key information. Crucially, it also calculates and shows the exact retrieval steps, which items need moving to get the one you want. This is vital for astronauts, saving precious time and effort, ensuring they can quickly grab essential gear. Our system tackles the complex ISS cargo management challenge head-on by providing robust inventory tools. Astronauts can easily update the station's manifest by adding new containers, defining their zone and exact dimensions, or inputting details for newly arrived items from resupply missions, including critical data like priority, expiry, and usage limits, which our placement engine then uses. Crucially, when an astronaut needs an item, the system simplifies the complex retrieval process, remembering that items can only be moved straight out from the open face and that blocking items must be cleared first. Our software calculates and presents precise, step-by-step instructions. It details exactly which items to remove, set aside, retrieve the target item, and then place back any obstructing items, showing 0 steps if it's already accessible. This automated guidance transforms potentially time-consuming searches and retrievals into a clear, efficient procedure, directly addressing the significant time astronauts currently spend on stowage operations. Now let's move on to our inventory data section, which provides a comprehensive overview of all stored items and containers on board. You can easily toggle between the items view, showcasing detailed information like status, expiry, remaining uses, and priority for all 2,000 entries, and the containers view, which lists all 56 units with their zones, dimensions, and even the total items currently inside. Powerful search bars and filters are available in both views, allowing astronauts to quickly find exactly the information they need, significantly streamlining inventory checks. Next, let's look at waste management, crucial for efficient ISS operations. Our system automatically tracks and identifies items that become waste over time, either through expiration or reaching their usage limit, clearly listing them with the reason, as you see here. To plan disposal before an undocking event, astronauts simply provide the designated container ID, the scheduled departure date, and the maximum return weight limit. Our core algorithm then intelligently selects which of these waste items should be returned, specifically optimizing the choice to best utilize the valuable, limited space and weight capacity of the undocking vehicle. Generating the return plan produces a complete return manifest detailing the items and provides precise, step-by-step retrieval instructions for moving each chosen waste item, specifying actions like retrieve or set aside. This automated planning ensures waste is packed efficiently and gives astronauts clear guidance, saving significant preparation time for return missions. Moving on, let's explore the Simulate Item Usage feature, which is vital for effective mission planning and resource management. Astronauts can select a list of specific items they anticipate needing over a future period, as shown here, and then choose a target date to simulate up to, in this case, July 22, 2027. When they click Process, the system essentially fast-forwards time, applying the expected usage and checking expiry dates for each day simulated. The results provide critical planning insights. The Items Used tab displays the simulated usage count and the calculated remaining uses for each item. Importantly, the simulation also automatically identifies and lists any items expired by that future date and highlights items depleted, which are projected to completely run out of uses. This powerful foresight is invaluable, allowing crews to anticipate potential resource shortages well in advance. Finally, every action is logged with details for full traceability and accountability. Thanks for listening.